After you start working with linear functions, so the basic next step is for you to work with other type of functions. It means that you're going to start working with polynomial functions that uses a highest degree than the linear function. In this case, it will be the quadratic function. If the linear function is y equals mx plus b, so the quadratic function should have a term that has a square. And this is what we're going to see in this video. The objective of this video is to observe how we're going to analyze a quadratic function. So I hope that you enjoy it. I'm Agofim, and I hope that you like this video. Let's go to the board. So the quadratic function is a function whose form is ax squared plus bx plus c. Now, if you remember how to get the y-intercept of a function, so the y-intercept of a function is just when you calculate the function when x is 0. So this means that if I use x equals 0 here, the y-intercept is going to be c. So this is the first part that you can see to analyze a quadratic function. Any quadratic function is going to have the y-intercept for c when it's in this form, ax squared plus bx plus c. Now, any quadratic function, it's going to have as a graph a parabola. So the parabola is this form. Could be this form or could be this form. Any of these forms are represent a quadratic function. Now, how do we know if it's concave up like this one or concave down like this one? The key to know if it's concave up or concave down is given in A. The term A is going to tell you if it's concave up or concave down. If A is less than 0, so it's a negative number, so it's going to be concave down. But if A is a positive number greater than 0, so it's going to be concave up. It's going to have this form. And according to the graph of the quadratic function, we can also going to have a turning point or a vertex. So the turning point of the vertex will be the maximum point if it's concave down or the minimum point if it's concave up. And a quadratic function has something cool that it's a line of symmetry. It means that you have a line that is going to divide your quadratic function in a reflection of itself. And this is very interesting to analyze and to sketch and to know how it is a quadratic function. To find this vertex, we can apply many methods, but the best way is that you convert this function or this form that in some papers calling standard or in some parts they're just calling the polynomial form into the vertex form. So the vertex form, it's going to be just f of x equals a x minus h to the second power plus k, in where the vertex position is going to be in hk. Now maybe you will ask why here is negative h and why here is positive k, and this becomes from the form of the function. So if you graph, by any chance, if you graph the function x squared, let's say that you graph the function f x squared, the function x squared is going to have this form. Now, if I move, the vertex of this function is at 0, 0. But if I move this function some units to the right, let's say h units to the right, the new function, I'm going to put it in red, the new function is going to be a translation in x of this function, of this original function. This will be a translation of this one. So this is why it's going to be x minus h, because it's a translation in x. And if I want to move it up k units, let's say that this is k, so I'm going to move this function up k units. Look at that, my new vertex is hk. But what I'm doing is moving up the function, and this translation is going to give you ax minus h squared plus k. So this is just a translation of the function x squared. You translate functions x squared. In my tube, you can find other videos about how to do translations, so you can understand what I did here. But this is going to give you the vertex form of the function. Now, there are many methods to convert this function into this form. I'm going to record a video soon explaining you how to convert it into vertex form. This is not part of this video, but what I'm going to tell you is the results of the other video that you can search in other sources. That is that h can be expressed in terms of a, b, and c as minus b over 2a. And k can be expressed as c minus b squared over 4a. And this is quite of an advantage, because if you have your function in polynomial form, you can convert it into vertex form to analyze the function and to get the lines of symmetry and to get many forms, okay, to get many information from this function. So I'm going to do it with an example. So we're going to use an example to analyze the function. So what I'm going to do is to analyze, I'm going to analyze the function fx equals, I'm going to use 6x squared minus 24x plus 3. Okay, so this is the function I'm going to analyze. I'm going to see how this function works. Now, what I recommend you to starting analyzing a function, a quadratic function, I recommend you to start by finding the vertex. Because if you find the vertex, you're going to have many information from the function just with the vertex. And this is why the vertex is very important for quadratic functions. Because the vertex is going to give you a lot of information to analyze your quadratic function. So let's start calculating the vertex. So I'm going to use my equation, my formula to calculate my vertex, minus b over 2a, and k c minus b squared over 4a. I'm going to use that. So in this case, I can find out that a is 6, that b is negative 24, and c is going to be 3. So now I'm just going to use my formulas to calculate my vertex. So this is going to be minus b is negative 24, over 2, and a is 6. So h is going to be negative times negative positive. 6 times 2 is 12, and 24 divided 12 is 2. So 2. And now I'm going to calculate k. So k is going to be equal to c is 3, minus b squared, so it's 24 to the second power. Look at that, I didn't put negative because negative times negative is positive, so it's going to be the same number, over 4 times a, that is 6. Okay, I'm going to simplify this fraction here. So 24 to the second power is just 24 over 24. 4 times 6 is 24. So 24 with 24. So the answer of this factor is going to be 24. So this is going to give me 3 minus 24. So k is going to be negative 22. Okay, so as you can see, what I just find out is that my vertex is in the position 2, negative 22. This is the vertex position of my function. Or if you want to write it in vertex form, this implies that if I want to write it in vertex form, the function is going to be a, that is 6, times x minus h, so minus 2 to the second power, minus 22. Okay, so this is the vertex form of this function. What implies this form? What implies this form? I'm going to use here, I'm going to try to do here kind of a graph. So this implies that my graph, oh my god, my graph if I want to plot it, so it will be 2 and negative 22. So I'm going to use 5, 10, 15, 20, 25, 22. So see that here is 22. My vertex is here, 2 and 22. So now I already know that this is going to be the point. But there is something more interesting about this point, that as the quadratic function should have a line of symmetry, the line of symmetry passes the vertex. So it means that the line of symmetry passes this vertex. This is the line of symmetry. So I can state that the line of symmetry is the line x equals 2. This is the information you can get from the vertex form. When you have it in vertex form, immediately you know that the line of symmetry is just x equals to 2. This point, the x coordinate of my vertex, should be the line of symmetry, because the line of symmetry cuts my quadratic function in two parts. This is what you can see here. So you have your vertex and your line of symmetry. Now, remember that the y-intercept is going to be c because it's when x equals 0. So if x equals 0, the y-intercept is going to be 3. So in this case, the y-intercept is going to be 3. So you can put 3. So the point 3 is going to be, I'm going to assume that is here. So my point of my y-intercept is here. But this is something, there is something pretty cool about the line of symmetry. As this is a line of symmetry, the distance to the line of symmetry should be the same, right? So it means that here the distance from this coordinate 0, 3 to the line of symmetry is only 2 units. So I just can move 2 units. So 3, 4. And this point, 4, 3, is going to be part of the parabola. Is going to be part of the parabola. And if you observe, A is positive. So the parabola is concave up. Okay, because A is 6, that is greater than 0. It's concave up. So the turning point is a minimum. This is something you can observe just by graphing these 3 points, that the vertex is a turning point, but it's a minimum. Look, so the graph, just by looking here, is going to be this form, symmetric, and look at that, it's going to have 2 x-intercepts. 2 x-intercepts. So it's going to cross the x-intercept twice. Now we're not going to calculate in this video x-intercepts because it's going to be longer, and I already have talked for 14 minutes, so it's a lot. But this is the main idea of analyzing a quadratic function. Now what we're going to do, finally we're going to get domain and range. So I'm going to use the graph to tell you domain and range. The domain is just going to be all real numbers because it's just a polynomial function. Polynomial function, the domain is all real numbers. And the range, so it's all the possible values of y. Obviously they are real, but take into account that the number, oh my god, I think I did it wrong, the y-intercept, because I put it in -3, not in +3. But let's change it. Some mistake. So I'm going to put that +3 is here. So the y-intercept is here. And at 4 is going to be in 3. Even so, it's going to have 2 x-intercepts. Like this form and this form. Okay? Now, finally, the range is going to be the numbers starting here at -22 and getting to infinite. So you're going to have y greater than or equal to -22. This is how you analyze a quadratic function. So, to sum up, how to analyze a quadratic function? First, find the vertex. Find the vertex. You can use these formulas to find the vertex. And I recommend you to put it in vertex form. The vertex form is going to tell you where is the vertex, and it's going to tell you the line of symmetry. The line of symmetry is going to help you to get the form of the function, and the A is going to tell you if it's concave up or concave down. And finally, you can calculate the domain and range using the information you have and to sketch the graph. And that's it. This is how you can analyze quadratic functions. I hope that this video is not too long for you and that you get the idea. Just write your comments, write if you don't understand something so I can help you, and see you in the next video. Bye bye.